What's up, crew? It's our final 5-minute lesson of the year, 12.6. You have done so much math this year. I'm so proud of you. And I'm also very appreciative of you working with this new course and giving me time to build all these videos, the way you've used your resources. I'm just proud of this room in general, okay? All right, probability and decision making. Let's take a look at this game. Your friend offers to play the following game with you. If the product of the roll is 10 or less, I win. If it's not, you win. Would this be a fair game to play? Well, there's no way to answer that until you get your hands dirty and start writing some things out. Let's see. How would I best write this out? Well, on roll 1, you could get a 1, a 2, a 3, a 4, a 5, or a 6. And then on roll 2, you can get a 1, 2, 3, 4, 5, 6. So immediately I start understanding this is going to be a large chart. How many different outcomes are there just if I roll a 1 on my first die? I could have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. How many outcomes is that? 6. So how many total outcomes are there going to be? 36. So now I've got to kind of start, without writing all of these down, I got to write all the outputs. Okay? So what's 1 times 1?
1.
Okay? 1 times 2. 1 times 3, 1 times 4, 1 times 5, 1 times 6. I'll draw a little line. What if we went 2, 1? That would be a 2. 2, 2.
4.
6, 8, 10, 12. Break. Okay? 3, 1. 3, 3, 2. 6, 9, 12, 15, 18. 4, 1. 4, 2. 12, 16, 20, 24. 5, 1. 5, 10, 15, 20. And then 6, 1.
6, 12, 18, 24, 30, 36.
Now, if this game is fair, how many of these will be below 10? Half of them. Very good. 18 of them. But half is the number that's more important. I think the thing for us to do now would just be to start circling. We'll circle all of them. Let's see. If the product is 10 or less, winner, winner. 10 or less. So that's a winner. Winner, 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 winner. I think that's all of them, right? Did I miss any that are 10 or less? Now I got to count them. 6 plus 5. 11 plus 3 is 14. 16. 18. 19 winners. So it's almost a fair game. It would be a fun game. You still would have a decent chance of winning on either side. But no, it's not a completely fair game. Okay? Uh-oh. All right. I should have substituted it with some of the names in this class, but I didn't. But so now we're talking about Sadie, Tamira, River, Victor, and Jay. 2 of these 5 people will be selected to win the game. How can we create a fair situation to do this? Well, I'm just going to show you. There's a lot of ways. Like, what would be like the old school way to do it? maybe like put all their names on an exact same size piece of paper, fold that paper up, put them into a box, and pull 2 out. That seems fair, especially if we jumble up the box. But if we were worried about that being fair, we could use our good old graphing calculator. So now I'll show you how to do this. Under math, a lot of you guys have been using the probability for the factorials. So maybe you've seen this random integer button. I'm going to hit random integer. The lower value is 1. The upper value is 5. This is not the same way that I did it on the other one. And I think that means we're picking 2 of them. Oh, we picked 5 twice. Oh, this is interesting. So now I think what we would do is go back and go random integer 1 through 4 and just pick 1. Math, random integer 1 to 4, 1. And so the students that will be going on the trip will be Sadie and Jay, lucky winners. You got a problem with that?
No, I mean, like, it's weird how we got the same thing.
Well, it's random. So, like, that's what makes something random. We're picking 2, and it just so happened that randomly, because there is a likelihood that you pick the same number twice. What is that likelihood? Just 1 out of 5, right? So that's not that out of line. 20% chance that we were going to get the same number twice. Did you?
Yeah.
That's weird. Weird. Oh, okay. I'd be curious if everyone did that.
Yeah, I also.
Everybody got 5-5?
I got 5-5 and I got 1.
Did everybody get 5-5 or did anybody get like 2-2? Maybe there's an issue with the random, or maybe we're not using it right. When I looked up how to use that, that was not how it looked on my end. But
I started spamming the 5-5 one. They gave me different results, so I think it's fine.
Yeah, I just did
Just
it again.
oh, you did?
Yeah, I started spamming it and it gave me different answers.
Oh, but I got the same the second time.
You did?
Yeah, I got 3-3,
4,
Oh yeah, I got
1,
2-2 my second time, I think.
and then I got 4-1.
2-5?
Yeah.
Shut up. This is not random at all.
Wait, 4-1-2-5?
Okay.
Yeah, 3-3, 4-1, 2-5.
All right. Well,
Wow.
2-4-5-2.
we're going to have to contact Texas Instruments. Turns out we'd be better off putting them into a hat. Remind me, I'll tell you a really, really, really sad story about this at the end of this lecture, okay? All right, so this is like when we talk about statistics as decision science, we mentioned that last week. This is it right here. This is like what your parents do for their job. Not all of them, and not exactly this, but like this is what adults do. They're paid to like look at a lot of data and make decisions that will save companies money. Okay. So you can read all this. I've already read it a few times. Let's go, Drew. I got a meeting during lunch, but I'm hoping to come by. Okay. Thank you. Okay. All right, so we're selling these tablets for $150. That's not changing. Basically, this one, what's the difference? They have the same model number, which is really stupid, right? Aren't they exactly the exact same model number? So I'll just have to describe this one as the one on the right, and this one is the one on the left. Any good business would have just put like another letter there, like B, so we can refer to them. But anyway, it's not a business, it's a math. So this one costs a little bit more per year, the one on the right, to make. But this one fails 5% of the time. And if they fail, we have to replace it. Where this one only fails 1% of the time. It costs a little bit more to make, and it costs a little bit more to replace, but it doesn't fail as often. If you were the head of production, would you recommend, oh, that's what happens. They meant to put a 1 here, but the person didn't copy and paste it right. Because look, it says 5,000 or 5,001 down here. So let's figure out the average cost or the average profit from the 5,000. So we got 5,000 here and 5,001 here. Okay? So the profit is equal to the cost minus the sale. Okay? No, the sale minus the cost. Jeez, Pete's. Profit equals sale minus cost. Okay? So this one, we sell it for 150. It costs us 100. But 5% of the time, it costs us $130. So that's going to be minus 0.05 times 130. Okay? This one is also going to be sold for 150. It costs us 105 to make, so it costs us more to make it. But this is going to be 0.01 times 135. Can anybody help me? I know you can't read this that easily. Does anybody have a calculator handy that can help me with this? Liliana, can you do 150 minus 100 minus 0.05 times 130?
43.5.
$43.50. Okay, now can you do 150 minus 105 minus 0.01 times 135? 0.01, 135.
43.65.
Okay? So this is our average profit. So which one should we recommend creating or producing from here on out? The 5,001. 15 cents per machine may not sound like a big deal, but if you sell, these to schools, how many students are in our school district in Sycamore? Anybody know? Like maybe 4,000? So if everyone in the school, just our school district, got this, the company would make, what's 4,000 times 15 divided by 100? $450?
600.
600. So they would make an extra $600 from our district alone, just from our district. Now think if you could get into maybe 10,000 school districts US wide. Now we're looking at real numbers. We're almost to $1 million now, $600,000. Okay, so we want to go with this one. I think that's the end. That might be the last slide. Do you want me to include the sad story?
Yeah.
Okay. It's about the draft. Do you guys know or guys and girls know what a draft is for the United States Armed Services? What is that? What's a draft?
They like pick.
Where they wrote everybody's name down and then they picked them to.
Okay, that's right. It's, you get selected, you don't have a choice, and you are going to serve your country in one of our 5 branches of the armed service. And, basically the less capable you are of doing work, the more likely you would be to be put on the front lines. So it's a very scary thing. Our last draft was for the Vietnam War, and I think it was in the late 60s, maybe early 70s. And so they wanted to come up with the fairest way they could to do this, so they went old school. They went with ping pong balls in a huge hopper. You know what a hopper is? Like something that spins around?
Yeah.
Exactly, it's just like bingo. And then they thought, okay, we'll put everyone's birthday in, and then the way it worked is you got drafted based on, if you were 18, you were draft eligible. So this was just for 18-year-olds, okay? This is gonna affect you guys. Let's hope not, but you should know how the rules work. You should know whether or not the draft is still a thing. I won't spoil that for you. And you should appreciate the people that do serve our country. I believe that. But they did it by putting the balls in. But how? Do you have any idea how they put the balls in?
Oh, I'm not.
They went in order. So they went January 1st, January 2nd, January 3rd, January 4th. You follow me on this? And then all the time that hopper was spinning. So then they just kept going. Now, like, imagine just from like a scientific standpoint, which balls are going to be like in the middle of that big group of balls? Or think about it this way, where do you think December 31st is going to end up? On top, or at least on the exterior of those balls. So the January balls are going to be insulated in the middle of that big group of balls. And then the November and December balls are going to be spread out, but all spread out throughout the outside of this mass of balls. Does that make sense? So you should go look at the draft results. If you were born in December, you were screwed. You were absolutely drafted. And if you were born in January, you were not going to be drafted. And that's the way it turned out. Like the way it really turned out. If you look at it. And then nobody recognized the error in that until it was too late. So that's how it turned out. It's a true story. I learned it when I was in college from my decision science teacher. And I'll never forget it. All right. Thanks for listening. Boom.